this chapter, we will explore how networks are represented visually and the different topologies used to organize network components. Understanding network representations and topologies is crucial for designing, implementing, and troubleshooting networks, effectively network representations. Symbols and icons. Network diagrams often use standardized symbols and icons to represent different devices and connections. For example, a computer icon may represent an end device, while a switch icon represents an intermediary device that connects multiple devices. Physical versus logical representations. There are two main types of network representations. Physical representations show the actual physical layout and location of devices and cables. Logical representations depict how devices are connected logically, regardless of their physical placement. They focus on the flow of data between devices. Importance of representations. Network representations provide a clear, visual way to understand how a network is structured and how data flows through it. They are essential for network planning, troubleshooting, and documentation. Network topologies. Network topology describes the geometric arrangement of devices on a network. There are several common network topologies. Bus topology. Description. All devices are connected to a single cable or backbone. Advantages. Simple to implement and cost-effective for small networks. Disadvantages. Single point of failure, limited scalability, and performance issues as the network grows. Ring topology. Description. Devices are connected in a circular fashion, with data traveling in one direction. Advantages. More reliable than bus topology, as data can travel in both directions. Disadvantages. Complex to implement and troubleshoot, with a single point of failure. Star topology. Description. All devices are connected to a central intermediary device, such as a switch or hub. Advantages. Easy to implement and troubleshoot, with no impact on other devices if one fails. Disadvantages. Relies heavily on the central device, which can be a single point of failure. Mesh topology. Description. Each device is connected to every other device, creating multiple paths for data to travel. Advantages. Highly reliable and resilient, with no single point of failure. Disadvantages. Expensive to implement due to the large number of connections required. Tree topology. Description. A hybrid of bus and star topologies, with a central backbone and branches of star networks. Advantages. Combines the benefits of bus and star topologies with improved scalability and reliability. Disadvantages. Complex to implement and troubleshoot, with potential single points of failure at branch points. Choosing the right topology. The choice of network topology depends on factors such as size of the network. Larger networks may require a more scalable topology, like tree or mesh. Reliability requirements. Mission-critical networks may need a highly reliable topology, like mesh. Cost considerations. Bus or star topologies are generally more cost-effective to implement. Conclusion. Network representations and topologies provide a foundation for understanding how networks are structured and how data flows through them. By mastering these concepts, you'll be better equipped to design, implement, and troubleshoot networks effectively. If you enjoyed this episode, don't forget to like, subscribe, and hit that notification bell so you never miss an update.